elliptical. Rough diagram. Can we call this as a perigee? This you call a perigee. So we know what are the radius of the RE, this distance he has given, RE. Two RE, radius of the Earth, 2 RE, this is 4 RE. First we'll calculate what is the orbital speeds of the satellite in the orbit 1, orbit 2. These are very popular, some around 4 or 5 questions are there, just go through once. Anything related to that you can manage here. First we'll calculate the orbital speed. What is the speed of the satellite in the, that should be equal to GM by 2RE. So this, if I adjust this, this will become root of GRE by 2. You have to give value. Similarly, orbital speed of this GME by 4RE. So GRE by 4. G, radius of the Earth. This I solved in junior class. That I am having a data. Last week, gravitation chapter was there. Okay, this much of orbital speed are there. So it was moving in orbit with a speed, how much satellite? 5,656. It has to be sent to higher orbit of radius 4RE, where the orbital speed will be 4,000 meter per second. So that has to be accomplished what? Through transfer orbit. And there's a transfer orbit already in the diagram indicated. So now from V1, I should make the velocity to perigee, no? Perigee, all of you. Shall I put the one which is near to the focus? That will be perigee. Further point from the focus will be apogee here. So what is the velocity of the satellite needed at perigee and apogee? That has to be calculated. I think what we know, this distance is what we have, 2RE. And what about the further distance? Will be 4RE. Shall we apply the conservation of angle between perigee and that one? VP into 2RE, mass of satellite should be equal to mass of satellite into VA into 4RE. So this should be VP is equal to 2 times of VA. There's a one equation. Applying conservation of angular momentum between perigee and apogee for the transfer orbit. Then applying conservation of mechanical energy. So next equation, mass of satellite VP square by 2 GME MS by 2RE. I'll write down, you later on if you can work out. I think directly you can also bring V1 square here, no? GMEMS into RE, that one. So you can bring in terms of V1, V2 also. Or in terms of GRE, you bring it. One RE, you adjust it here. MS will anyway get eliminated. So this will become VP square by 2 is equal to VA square by 2. 2, okay, 1, 4. GMERE. So we can write it as GRE. GRE. So will I agree this? So some adjustment I made. This 2 should not be there. Yeah. Because what you can write, what is G is equal to? GME by RE square. So where all you want, you can bring G into the picture. So we know all the things. So these are the two equations to unknown. Solving that, we'll get the speed of the at perigee and apogee. At perigee, it must have a speed. It's this one. At apogee, it must have a speed of. In exam, I think you should be very fast. They may ask this in compression, or sometime they'll ask this as objective. I don't know how you manage with the high speed calculation. These are the required speeds. You look at that one.
Sir, you gave VP equal to 2VN or sir, calculation it will be wrong.
Apogee. Sorry, this is apogee. Perigee will be 876. This apogee. Which one?
Here you give VP equal to 2VN or sir, this is not satisfying that equation.
What is not satisfying?
The values of VA and VP won't satisfy the equation on the left bottom, sir.
These values, huh?
Yes, sir.
Two 292 and 146.
292 and
146.
oh, that much only, yeah.
Kilometers.
Kilometer, huh? Meters. Just give the some values, huh? Hari convert into meter radius. Okay, this one. Apogee 32. Perigee should be twice of this one. Check it now. It'll be this much only. Check it. Huh? Okay, now I got it. So now we're asking, what is the minimum energy required for the transfer? What do you mean by minimum energy? With what speed it was moving in the first orbit? In the first orbit, it was moving with a speed 5,656. So how much it has to be? 6,532. So shall I increase speed? Shall I supply energy, or shall I take out energy from the side? I should supply energy to the satellite, no? What is the velocity? Initial velocity change should be Vp minus V1. Initial velocity changes. Final velocity changes. Va is initial. V2, it should be final, it should acquire. So Va is how much? 3,000, this one. It has to be again at apogee, it should be fired. The rocket weapon should be fired at both perigee and apogee. So I'll put changes. Change in speed at perigee. Shall we write here? Delta V initial, I'll call it. This should be equal to 6532. Let me directly substitute this thing. Now similarly, change in speed at apogee. What is the final speed in the orbit? 4,000. And at apogee is how much? Okay, this is the thing. These are the changes. Next again, what is the minimum energy required for the transfer? What do you mean by energy? How to calculate? I think the energy needed, I'll write it here. Okay, we can slide down. Yeah. Delta E, the total energy to be supplied. Mass of satellite perigee is how much? Vp square by 2. V2 is greater, no? Please do look at the calculation. You should take like this. So who will do that one? The rocket will be fired here. This is more economical. Practically, this will be more economical. Answer. I'm getting 2 point. You check later on. This much of energy should be supplied. Both at perigee and apogee, energy must be supplied. So shall we put a comment like energy supplied to satellite at perigee?